All right, so looking at this, we are doing a Unit 3 and Unit 4 test together. So remember, this is going to be looking at combining systems of equations, which was Unit 3, and then matrices, which was Unit 4. So we're going to do a little bit of the examples for each one. Make sure as you're working this at home, if you want to make notes, that's fine. I will leave some of the questions blank for you to try as well to make sure you're understanding those. Okay, so the first section, no calculator section. So right here, without graphing, we do have to classify the system as consistent and independent, consistent and dependent, or inconsistent. So we don't want to graph these. So looking at it, you do still want to get y by itself. So y is already by itself for this one, so we're good there. We do want to get y by itself for this equation, so I want to move the 2x over there. Remember, if it's a positive on this side, when you move it over, it is going to turn into a negative 2x. I still have that minus 14 that I brought down. And then the last step, you are going to divide everything by 4. So getting this one, y by itself, negative 2 over 4, which reduces to a negative 1/2 x. And then minus 14 over 4, we can just leave it like that as a fraction. You can reduce it. So realizing they're both divisible by 2, so I can reduce that to a 7/2. Okay, so without graphing, how do I know what it is? So the biggest concept here is your slope. So realizing this slope is a negative 1/2 and that slope is a negative 1/2. So automatically, because they have the same slopes, you know these lines are going to be parallel. So looking at that, they are parallel lines. They also have different y-intercepts. So they have the same slope, but different y-intercepts. That tells you that these two lines are never going to cross. They're going to be parallel lines, which would make that a no solution. So when I'm looking at labeling that, a no solution is just that inconsistent. So I would label that one as an inconsistent. Okay, so the key concept here is you're looking to see about their slopes. So if I look at this one, again, I want to get y by itself. I'm going to move the 3x to that side. That positive 3x will become a negative 3x. And then I do still have to get rid of that 6. So I'm going to divide everything by 6. So that equation would be y equals, remember, negative 3 over 6 is going to reduce to a negative 1/2. And then 18 divided by 6 is 3. So that's that first equation. Looking at this second equation, move that x over. So I'm doing the same steps. That positive x is going to become a negative x on this side. And then I'm going to divide everything by 2. Okay, so now looking at this one, realize, remember, if I don't see a number, there is a 1 there. So that's going to be a negative 1/2 x. So already I see the same slope again. Whoops. But now looking at that, 6 divided by 2 is 3. So when I look at that, realizing these are the exact same equation. So if you were to graph this, it's going to be the same line. So unlike this one that was parallel, even though they had the same slope, they had different y-intercepts. So this one is parallel. That's the inconsistent. There is no answer for this one. This one, it is the exact same line. So with that, it is going to be a consistent. And then looking at that, that is going to be your dependent because they're the exact same line. Okay, so you have to be able to take an equation without graphing it, look to see what type of solutions it's going to be. Okay. The second section, we are actually going to graph these. Okay, so I am going to go through and graph that first one. So looking at this, again, same concept. I have to be able to get y by itself. So that positive 2x is going to become a negative 2x on the other side. Make sure right here you realize that negative, that subtraction drops down as a negative with your y. So I still have to divide everything by a negative 1. So that equation, negative divided by negative, is a positive. And then positive divided by negative is a negative 5. So that's my first line. So I'm going to go ahead and graph that one. Remember, we always graph your y-intercept first. So I'm going to go down to negative 5 and put my first point. And then from there, we do our slope. Our slope is rise over run. So I'm going to go up 2 and over 1. Up 2, over 1. And you can continue that for as long as you feel like you need to get your line. Okay? So if I can draw a straight line. There you go. So that's that first line. So now I'm looking at the second equation. So again, I still have to get y by itself. I have to move that x over there. So that's going to become a negative x plus 6. And then I'm going to divide everything by 3. Again, don't forget there's a 1 there. So that's going to be a negative 1/3 x plus 2. So now I'm going to graph this line. So I'm going to start here at 2 because that's my y-intercept. And then my slope is a negative 1/3. So realize that negative is going to tell me I'm going to go down 1, but I'm still going over to the right 3. And I can already see that that's where they're going to meet. But I'm going to go down 1 and over 3. Okay, so that would be my line. I need to kind of turn my paper to get a straight line. There we go. So that's how I'm going to graph them. Now looking at that, finding that intersection point, again, I noticed it right here when I was doing my slope. That would be my solution. So when I look at that ordered pair, that is 1, 2, 3. So I go over 3, up 1. So that would be my solution for that one. That's the one point that they have in common. Okay? So looking at the next one, you're doing the same concept again. So I'm going to get y by itself, so I have to move these over. Don't forget that's a negative 3y that you have left. That becomes a negative 2x plus 3. And then I'm going to divide everything by negative 3. So I get y equals, don't forget, negative divided by negative is a positive 2/3 x. And then 3 divided by negative 3 is negative 1. So I'm going to go ahead and graph this one. I'm going to start down here at negative 1. And then my slope is 2/3. So I'm going up 2 and over 3. And then up 2 and over 3. So that's going to be my first line. And then second line, get that y by itself. This one's a little bit easier because I don't have anything to divide by. So I'm just going to move that positive x to the other side. So that gives me negative x minus 6. So I'm going to go down to 6. So 1, 2, 3, 6. So there's negative 6. And then my slope is a negative 1. Again, don't forget there's a 1 there. So I'm going to go down 1 over 1, down 1 over 1. Okay, I can go up 1, but if I go up 1, I'm going to have to go over to the left 1. Up 1, over 1. Okay, and this one I probably didn't do a very good job drawing that straight line, but again, we're looking for that intersection point. So if I would have continued this pattern, which was 2/3, if I go down 2, 1, 2, 3, that was right there, that ordered pair, and that would be the one that matches up my up 1 over 1 there. So looking at that ordered pair, that is 1, 2, negative 3, and then 1, 2, down negative 3 as well. So that would be my solution for that graph. So when you are graphing these, you do need to make sure that you can continue those points. My line wasn't very straight right here, but if you continue those points, you're going to see one point that both of them have on their line, and that's your intersection point. That's your solution. Okay. Next part, we're doing the exact same thing, but these are with inequalities. So with inequalities, you do have to remember you have to shade part of your graph. So remember, if it's a less than or equal to, we're going to shade below. If it's a greater than or equal to, you're going to shade above. So you do have to color part of your graph. And then also remember, if it's just a less than or greater than, we're going to do a dotted line. If it is equal to, we're going to do a solid line. So those are your main concepts when you're looking at inequalities. Okay, so looking at this one, again, we're still getting y by itself. I'm going to move that 2x over. So that becomes a negative 2x plus 6. I'm going to divide everything by 3. So I have y is greater than, that's going to be a negative 2/3 x plus 2. So I'm going to go ahead and graph this one. So y-intercept, just like we did on the other two, I'm going to start up here at 2. Slope is negative 2/3, so I'm going down 2 and over 3. So down 2 over 3. Okay, now this is the one part that's different. So last time we just connected them with a straight line, and that was it. Here, we have to look at what type of line do I need to connect it with, and where am I going to shade. So looking at this one, it's not equal to, so when I connect these, I'm going to do a dotted line. Okay, and then I'm going to use a highlighter. When we look at this, I'm looking at shading above because it is greater than, so I would color everything above that line. So now time to graph the other one. So we do have to graph the other one. So again, got to move that x over. So that becomes a negative 2x plus 8. This one is the one to be careful of. Okay, so I have to get rid of that negative 1 on that side. I need to move it over. So I do have to divide everything by a negative 1. You've got to remember, when you solve inequalities and I'm dividing by a negative, I've got to flip that inequality sign. So this becomes y is greater than or equal to, that becomes a positive 2x, and that becomes a negative 8. So be very careful. This number right here, if you divide by a negative right there, you've got to flip that inequality into the other direction. Okay? If you forget that, then your graph is shaded in the wrong direction. So graphing this one, I'm going to start down at negative 8. There. And my slope is 2. So I'm going up 2 over 1. Up 2 over 1. And you can keep that pattern going. Now it is equal to, so when I graph my line, it's a solid line. And then the shading for this one, because remember we flipped our sign, so this is greater than. So looking at this line, everything that's going to be greater than that line would be shaded this way. So your solution is where those colors overlap. So your entire solution area would be right here. So that's your solution area for the inequality. So with inequalities, you don't have an ordered pair for an answer like we did up here. Your graph is the solution for those. Okay, so let's look at the next one. Same concept. I'm going to move that 4x over. So that becomes a negative 4x plus 1. So I'm going to go ahead and graph that one. Start up here at 1. And then my slope is a negative 4. So I'm going down 4 and over 1. Down 4, 4, and over 1. So that one's a pretty steep line. So looking at that, it is just less than, so it's a dotted line. So when I connect those, I'm going to do kind of a dashed line there. And then it's less than, so I would shade everything below that line. Now I'm looking at the other equation, so I have to move this x over. That negative x is going to become a positive. And then I'm dividing by 2. So this one, I'm not dividing by a negative, so I don't have to worry about flipping my sign. Don't forget there's a 1 here, so that would just be a 1/2 x plus 5. So I'm going to go up to 5, and that's your y-intercept. That's your first point. And then my slope is 1/2, so I'm going up 1 and over 2. Up 1, over 2. Okay, it's equal to, so when I graph it, it is going to be a solid line. And then the shading, it is less than, so everything below that line would be shaded. So your solution area is right here where all that double shading area was. So that would be your entire solution area. Okay, so with systems, one option is to graph them. Whenever you're graphing them, you're looking for that intersection point, the one point they both have in common. When you're graphing inequalities, you have to remember the key concepts of what type of line to draw and then where to color on your graph. Okay, now we go to matrices. So looking at matrices, remember we have different operations. So we have addition, subtraction, and we have simple multiplication right here. So with addition and subtraction, first make sure you can actually add and subtract. Remember, they have to be the same dimensions. Both of these are 2 by 2s, so that's their dimensions. We're right there, and that's going to be the same dimension as your answer. So I am just taking the numbers in the same position and adding them. So I'm doing 4 plus a negative 1 gives me 3. I got negative 5 plus 3 is negative 2. I have 2 plus negative 7 gives me a negative 5. And then I have 3 plus 4 gives me a positive 7. So that is my solution matrix right there, and the dimensions of that matrix is a 2 by 2. Sorry. So same concept here. Looking at this is a 2 by 3. This is a 2 by 3. So I can go ahead and subtract those. So this is the key thing here to make sure you're subtracting these numbers. So I'm doing negative 2 minus a negative 4. So some of you may get confused right there. So remember, I have negative 2 minus a negative 4. Anytime you have that double negative right there, you know it turns to a plus. So that's really negative 2 plus 4, which is a positive 2. Okay. Then here I have 3 minus 7 gives me a negative 4. 5 minus 5 is 0. And now I'm going down to that second row. So I'm doing negative 1 minus a negative 8. Same thing, negative 1 minus a negative 8. That double negative turns to a plus. So that's really negative 1 plus 8, which is 7. 6 minus 0 is going to be 6. And then negative 2 minus a negative 9, there's that double negative again. That gives you a positive 7. And my dimensions are the same as what I started with because, again, in order to add and subtract, they have to be the same. So that would be a 2 by 3. Looking at this one, this is that simple multiplication. So this is really just like distributing. I am multiplying the number on the outside to everything on the inside. So all of the elements on the inside are getting multiplied by 8. So 8 times 8 is 64. 8 times 4, 8 times 5. And then I'm going to multiply the bottom as well. So 8 times negative 1, 8 times 6, and then 8 times negative 2. So simple multiplication, you're just distributing, and that is still going to be a 2 by 3. So let's turn it over. All right, so this one, multiplication. So remember with multiplication, a little bit more steps in the addition and subtraction. So first we have to make sure we can multiply them. So this matrix is a 3 by 2, and then this matrix is a 2 by 3. So remember, in order to multiply, these two numbers do have to be the same. So we're good there to multiply, and this tells me that my answer should be a 3 by 3. So I know before I even start multiplying that what my matrix should look like for my answer. Okay, so now multiplication, we are going to take the first row and multiply it by the first column. So I'm doing 11 times 0, which is 0. And then I'm doing 7 times 4, which is 28, okay? And you are adding those two answers together. Then I'm going to do the same thing. I'm taking the first row times the second column. So I'm doing 11 times negative 5, and then 7 times negative 3 is negative 21. And then last row, last column, I got 11 times 2, and then 7 times 1. So that's going to give me my first row of my answer. Now I'm taking the second row and doing the exact same steps. So now I'm multiplying the second row times all three of those columns. So 1 times 0, negative 5 times 4. So then I have 1 times negative 5, negative 5 times negative 3. 1 times 2, and then negative 5 times 1. And then the last one, last row, times all three. So 2 times 0, 3 times 4. I got 2 times negative 5, 3 times negative 3. And then 2 times 2, and 3 times 1. So all of that multiplication, again, row times the column. So now simplifying this, I'm just going to add these together. So I have 0 plus 28. I have negative 55 minus 21. It's going to give me a negative 76. 22 plus 7 is 29. Then I got 0 minus 20, then negative 20. Negative 5 and 15, 10. 2 minus 5 gives you negative 3. 0 plus 12 is 12. Negative 10 minus 9 is a negative 19. 4 plus 3 is 7. So that would be your answer matrix, okay? And it did end up being a 3 by 3, like we said in the beginning, okay? So with matrices, addition and subtraction, pretty simple. The multiplication one is the one where you have a couple more steps. All right, solving the matrix equation. For this one, I'm looking on the inside, so I know this right here is something I need to solve because it has a variable in it. And in the same position over here is the 9. So that's how I'm going to set up my equation. So I know it equals 9. Solve it like a normal equation. So I am going to add 3 over here to 9, which gives you 12. And then I'm going to divide by 4, so I know x equals 3. If I look at another variable, I have another variable right here. So 3y, and in the same position is that negative 15. So I can go ahead and simplify this one by dividing by 3, and I get negative 5. And then last one, I see another one right here, so 2z plus 1, and in this same position is the 13 on that side. So that's how I can set up that equation. So I'm going to subtract 1, which gives you 12, and then divide by 2. So that gives you 6. All right, still dealing with matrices. We're going to calculate the determinant. Remember, they can write it like this, which is absolute value bars, or they could put the letters DET for determinant in front of the matrix. So determinant for a 2 by 2, pretty simple. I am going to multiply this first diagonal. So 3 times 6 is 18. And I am going to subtract that diagonal. So 2 times negative 5 is a negative 10. Again, double negative right here. So that double negative turns to a plus. So your determinant is 28. Okay, so with a 2 by 2, you take the two diagonals, multiply them. So 3 times 6 was 18. 2 times negative 5 was negative 10. And then you subtract them. Now with a 3 by 3, a little bit more because I need to add in 2 more columns to get those diagonals. So I have to repeat the first 2 columns. So looking at that, I need to repeat those first 2 columns. And now I'm going to look at the diagonals. So I'm going to multiply the diagonals going down. So I'm looking at this one. So 1 times 4 times 2 gives me 8. Multiplying this one, pretty simple, because anytime I see a 0, I know that's going to equal 0, and I'm adding all these diagonals together. And then I have negative 2 times 0 times 5, so that's another 0. So that's that first set of diagonals, and you're adding those together. So now I'm going to look at the other set of diagonals, and remember, you're going to subtract these answers. So this diagonal, I have 3 times 4 is 12, times a negative 2 is negative 24. And for this one, I have 5 times negative 1 is negative 5, times 1 is still a negative 5. So you could have put minus 5 right there or plus a negative 5. And then here, I see those zeros, so I know that's just going to give me 0. So you do the diagonals going down first, and then you do the diagonals going up second. Now we're going to subtract those 2 answers once we simplify. So right here, this is going to simplify to 8. Negative 24 and negative 5 give me a negative 29. Again, that double negative turned to a positive. So here, my determinant is going to be a 37. So determinants 2 by 2, pretty simple. The 3 by 3 is where you have to add the extra 2 columns to create those diagonals. All right, so the next section, we're finding the inverse of the matrix if it exists. So the inverse, looking at the inverse, to find the inverse, the first thing we do is 1 over the determinant, just like we did up here where we cross multiplied and subtracted. So that's what's going to go on the bottom here. So when I multiply this, 1 times 4 is 4. 3 times 2 is 6. So that gives me 1 over negative 2. So that's a negative 1/2. Okay. The other part of that, so this is the first step. That's always going in the front. The second step is switching around your matrix. So for the inverse, these 2 numbers is first diagonal, the 1 and the 4, switch places. So that becomes a 4, that becomes a 1. These 2, this diagonal, they don't switch places, they just turn to the opposite. So that becomes a negative 2, that becomes a negative 3. So this is how we first want to set it up. So you're always going to start with 1 over, and you're going to find the determinant of your matrix. So that was the 4 minus 6. And then that became a negative 1/2, and then this is where I switched around that matrix. So now I do have to simplify it, so that means I'm going to multiply everything in here by a negative 1/2. So negative 1/2 times 4 is negative 2. Negative 2 times negative 1/2 is a positive 1. Negative 1/2 times negative 3 is a positive 3/2. and then 1 times a negative 1/2 is just negative 1/2. So this would be the inverse. Okay. Same thing over here. So we're going to do the same thing. We're going to start with 1 over, and so I'm going to do this determinant. So I'm going to do 2 times 1 is 2. 3 times 1 is 3. So looking at that, that's going to give me a negative 1. Well, 1 divided by negative 1 is negative 1. So that's negative 1. Now I'm going to change around my matrix. So remember that first diagonal switches places. Second diagonal just changes to the opposite. And then if I simplify this, that means I'm going to distribute out that negative 1 to everything. Negative 1 is just going to flip all those signs. So that becomes a negative 1. That becomes a positive 3. Positive 1, negative 2. And that would be the inverse. So remember, with the inverse, we can just write it with a negative 1 up there. That represents that this is the inverse matrix. Okay. Still dealing with matrices, how to tell if they are inverses of each other. So here, I had to find the inverse. Here, they're giving me 2 matrices, and they're saying yes or no, are they inverses of each other? So here, I'm going to multiply the 2 matrices together. So I'm going to multiply that first row by the first column. So I'm going to do 1/2 times 2, which is just 1. And then negative 1/10 times 0 is 0. And then I'm going to multiply by the second column. So this is kind of a review of multiplication. 1/2 times 1. Negative 1/10 times 5 is going to give you a negative. I probably should have put a minus there. Negative 1/10 times 5 gives you a negative 1/2. Same thing, take the bottom row and multiply it by that first column. So 0 times 2 is 0. 1/5 times 0 is 0. Last column, 0 times 1. And then 1/5 times 5 is 1. So now I'm trying to see, does this give me one of those identity matrices? So 1 plus 0 is 1. Those cancel out. That's 0. That's 1. So is that an identity matrix? Yes. So are these inverses of each other? Yes. So to tell if 2 matrices are inverses of each other, you multiply them together, and then you see if you get an identity matrix. If you do, then they are inverses of each other. Okay. So on to the calculator section. So realize we just did all of that without a calculator. So now we're on that calculator section. Now this is going to be a review of solving systems by elimination or substitution. So you do have to understand both of these methods. So you have to be able to do both the elimination and substitution method. So here there's 4 problems. We're going to pick which ones we're going to do by elimination and substitution. So I'm going to say these first 2 are going to be by elimination. Remember, substitution is easy if you have a variable by itself that doesn't have a number in front of it. So these 2 are going to be easier by substitution. So we're going to do these 2 by elimination. So for elimination, I've got to get one of the variables the same. So I'm going to pick the y's, which means I got to multiply the top by 3 and the bottom by 2. So when I multiply the top by 3, that becomes 9x plus 6y equals 15. Multiply the bottom by 2, so that becomes a negative 4x plus 6y equals, and yes, you can use your calculator, so 27 times 2 is going to give you 54. So that's the first step of elimination, making sure we have a variable that's the same. So now looking at that, they're both positives. They're the same sign, so I need to subtract those 2 equations. So I am subtracting everything, okay? So right here, I'm doing 9 minus a negative 4. That gives you a positive 13x. These cancel out. And then I have 15 minus 54. And that gives you a negative 39. Okay, so now I just finished solving for x. So now I'm going to divide by 13. And you get x equals negative 3. So remember, that's just your first answer. You do have to have 2 answers for these, because remember, it's the ordered pair that they both have in common. So I found my x value. I now need to go back and find y. You can plug this x into either equation. It does not matter which one, you're going to get the same answer. I'm going to use the first one just because the numbers are a little bit smaller. 5's a little smaller than 27, and I don't have a negative. So I'm going to plug x in right there. So that is 3 times negative 3 plus 2y equals 5. Okay, so you're plugging it back in. 3 times negative 3 is negative 9. And then that gives you a two-step equation to solve. So now I'm going to add 9 over here. So I get the 14, and then if I divide it by 2, you get y equals 7. All right, so my answer would be negative 3, 7. So let's look at the next one for elimination. Same concept. You get whichever one you want to cancel out. So I'm going to cancel out the x's. Again, I'm going to end up multiplying by 2 and by 3, because that way it makes both of those x's a 6. So multiply, just make sure you multiply everything in the entire equation. So you are doing the 16 times 3. So multiply everything. Okay? Now, I'm multiplying, or I'm getting rid of the x's. They're the same sign, so I need to subtract, because 6 minus 6 gives me 0. That goes away. I have 10 minus a negative 9 gives me 19y. And then 10 minus 48 gives me a negative 38. And then when you end up dividing by 19, you get negative 2. So I know y equals negative 2. Again, I have to go back and plug that back into one of these equations. Doesn't matter which one. So I'm going to use the first one. So I'm going to do 3x plus 5, and my y is negative 2. So this gives me 3x minus 10, because 5 times negative 2 is a negative 10. So now I can solve it. So now I'm going to add 10, which would give me 15. Divide by 3, so x is equal to 5. So your answer for that one would be 5, negative 2. All right. So the elimination process, you are trying to eliminate one of the variables by either adding or subtracting the equations together. All right. Now, the other two I would do by substitution, because I have a variable by itself. So for this process, I need to get this y by itself. So I'm going to move that 3x over there. So that negative is going to become a positive 3x plus 25. Okay? So looking at that, the substitution part, I am going to take this and substitute that into the other equation, because I know this is what y equals, just like here we substituted negative 3 in for x. I know this is what y equals, so I'm going to substitute it into that other equation for y. And then it basically becomes a large equation to solve. Okay, so now I'm going to distribute the 3 out. That's going to give me a 9x plus 75. And then you just finish solving like normal. So I want to combine these, so that's going to give me an 11x. And I'm going to go ahead and move that 75 over, so I have 9 minus 75. Because remember, if it's adding here, I'm going to subtract it. And then I'm going to divide by 11. So x is equal to negative 6. So the first step of substitution is a little bit longer than elimination, but the second step is really easy. So looking at this, if I know x equals negative 6, this is always the easiest one to plug it back into, the one where you got the variable by itself. So if I know x is negative 6, basically I'm just doing 3 times negative 6 plus 25. And that gives me a positive 7. So I know y is equal to 7. So you have negative 6 and 7. All right, last one for substitution. This x would be easy to get by itself because it has nothing in front of it. So I'm going to move that negative 2y to the other side. So this becomes x equals, when I move that negative 2y, I already have a 0 there, so that's just going to be a positive 2y. Okay? So I am going to take this 2y and substitute it in for x into the other equation. So this is going to be 4 parentheses 2y. I still have minus 3y equals 15. Okay. Solve like a normal equation. 4 times 2y is going to give you that 8y. Combine like terms. 8 minus 3 is 5y. So y is equal to 3. So I know y is equal to 3. Again, this is the easiest one to plug it back into because it's already got one variable by itself. So if I'm trying to find x, If I plug that in, 2 times 3 is 6. So here my answer would be 6, 3. Okay, so even though we have done matrices with systems, we are going to do that here in a second, but right here you are going to have to show elimination and substitution on your test. So you need to make sure you understand both methods. All right, next part, getting back to some matrices. Looking at this, we're just going to write the system. So remember, when you're writing a system, your variables are right here in that second matrix. So all I have to do is match up those numbers with each variable. Now, so that's a 2x, that's a 5y. If that's 0, I don't need it to put a z because I don't have any z. So that would 0 would cancel out the z and it equals 13. So you're pretty much just writing it straight across. So like this one would be negative 3x plus y. We can put a 1 if you want to, but remember we don't normally see it. And then plus 2z equals 6. And then that last one, I have 4x. I don't have a y because it's 0, so I'm not going to put it, but I do have a minus 3z equals 5. And we're just writing them. We're not solving it right now, so we're just having to write that. Okay. Same thing over here, going straight across. I have 2x plus y equals a negative 7. Again, 0, I don't have an x, so I just have a 4y equals 9. So that's how you would be able to write those systems from those matrices. All right, find the area of a triangle with those vertices. So looking at this does go back to those matrices. It was a given formula that we talked about in class. So when we're finding area, I'm going to have a plus minus 1/2. And then these ordered pairs are going to be put into a matrix. So that first ordered pair is 5, 1. And then remember that last column is always going to be a 1. So I have negative 3, negative 1, 1. And then that last one, 0, 2, 1. So that's a set formula when we're finding area of a triangle with a matrix. Okay, so now I'm going to do this just like I did with the determinant. I'm going to copy down those first 2 columns. And I'm going to find that determinant by doing those diagonals. Okay, so right here, and I'm going to bring over my 1/2. So that first set of parentheses, I have 5 times negative 1 times 1 is negative 5. Here, pretty easy because I see that 0, so I know that's a 0. And then multiplying this last diagonal, I have 1 times negative 3 times 2 is a negative 6. So that's the first diagonals. Now I have the second diagonals. Those are the ones that are going up. So here, that 0 is going to cancel everything out when I multiply. Here, 2 times 1 times 5 gives me 10. And then that last diagonal, I have 1 times negative 3 times 1 is a negative 3. Okay, so simplifying this, negative 5 plus 0 minus 6 gives you a negative 11. Minus 10 minus 3 gives me 7. So I'm still just simplifying. Negative 11 minus 7 is negative 18. So that part is the exact same thing that we just did on the other side. Okay, that's just finding the determinant. Once I find the determinant, I now need to multiply it by 1/2 because it is a triangle. And remember, I can't have a negative area, so I'm doing a negative 1/2 times negative 18. So that is going to give me a positive 9, and we're going to say units squared because it is area. And so we're always going to square our units. So anytime you are trying to find area of a triangle, you just set up your matrix with the ordered pairs that they give you. That last column is always going to be 1s. And then you find the determinant and multiply by 1/2. All right, so now we got some word problems. I know you guys aren't fans of word problems. Word problems, there can be all different types. So there is no one way to do a word problem. So looking at this, the first thing you always have to do is define your variables. Do not forget to do that. That means if you're using X and Y, whatever variables you're using, you have to say what it represents in the problem. So I'm going to zoom out just a little bit. There we go. Okay, so looking at this, a group of students go out for lunch. 2 students have hamburgers and 5 students have hot dogs. The bill was $8. If 5 students have hamburgers and 2 students have hot dogs, the bill was $9.50. what is the price of each? And that should have in parentheses or a question mark. So looking at that, we are trying to find the price of hamburgers and hot dogs. This is where it's up to use. I am going to use B for hamburgers. And I'm going to use G for hot dogs. So that's defining your variables. You can use whatever you want. If you always want to use X and Y, you can do that as well. Okay, so setting this one up, realize we have basically like two groups. So we have 2 students who have hamburgers and 5 students that have hot dogs. And their total was $8. So I know that's my first equation. The other group, 5 of them have hamburgers and only 2 of them had hot dogs, and their bill was $9.50. So that would be setting up your system. Okay, now I'm going to go through for this one. Again, you can solve it however you want. It doesn't specify how you want to solve it. So looking at this, I'm going to set up my matrix in my calculator so we can kind of review that. So I'm going to solve it by using my calculator and put in a matrix for it. So remember, in order to put in a matrix, I'm going to hit second and that x to the negative 1 power. Now, these are the names of it, but I haven't put in a matrix yet. So I need to go over to edit and hit enter. And this is where you can put in your matrix. So right here, remember, if I'm putting in my matrix, the first part of the matrix is just the coefficients, the numbers in front of your variables. So that would be my first matrix. Then I have my variables. And remember, that is going to equal your solutions right here. So that one's going to equal your solutions. So if you need to write it on your paper, that's how I would set up my matrix. So my first matrix I'm going to type in is a 2 by 2. So you need to type that in, 2 by 2. And then here I'm just going to type them in. So I have 2, 5, 5, and 2. So that's my first matrix. So now I can hit second, quit, and go back to the home screen. So now I'm going to go back to second, x to the negative 1. I now have to edit my second matrix. So now I'm going to matrix B. Okay, matrix B is my solutions. So that is just a 2 by 1. So now I'm going to type in the 8 and the 950. So now I can go back to my home screen. Remember, anytime you want to go to a home screen, you just hit second and mode right next to it. That's your quit button. So now I've got them in. So now if I go back, second, x1, now I don't need to edit. I've already put those in. So now I'm just going to hit enter to get A on my screen. And then I'm just going to hit the x to the negative 1. And then I'm going to go back and hit B. So I need A, the negative 1 exponent, and then B. And now I can hit enter, and it gives me my solutions right there. So looking at this, knowing how I set it up, I know, and this is why it's important to make sure you define your variables. So I set it up to where H was hamburgers, and that's my first number right there. So actually I used B, didn't I? Sorry, that was H. So my hamburgers would be $1.50 each. My hot dogs would be $1 each. So again, you can do systems in your calculator using matrices, but just be careful. Here it didn't specify how I had to solve them, so I could do that. Up here, you do have to do elimination and substitution. So make sure you understand how to do both. Okay, almost done. So looking at this one, another word problem. So Dr. Ryan has a total of $3,000 invested in 2 different stocks. So you have stock A that pays dividends at a rate of 6%. Stock B pays dividends at a rate of 8%. If Dr. Ryan's dividends from the 2 stocks total $220 per year, how much did he invest in each stock? So I have stock A, so I'm going to use A, and that one was at 6%. Stock B was at 8%. So those are my 2 variables that I'm using, okay? Altogether, I know that's his total investment. So I know whatever A is and whatever B is, that was a total of $3,000 that he invested. So that's my first equation, okay? The second equation is talking about the dividends, and that's talking about how much total he got. So I know from the A, which is 6%, remember, we have to move the decimal 2 places to make it to a decimal right there, and I know B was 8%, he made a total of $220 off of those dividends. So all of those numbers are talking about the dividends. This is just talking about the total amount invested. So that would be my two equations. So again, I'm going to go and we're going to edit the matrix. So the first one is still a 2 by 2. I just have to go change the numbers. So remember, this would be a 1. That one's a 1. This is 0.06. This is 0.08. So there's my first matrix. Sorry, that's a little blurry. I don't know if that made it any better. Probably not. And then I'm going to go back to my home page, and I'm going to go to edit my second one. It's still a 2 by 1. This time, this is 3,000, and this is 220. Okay, so now I just put in my two matrices. So remember, I now want to put those on the home screen. So I want A, I'm going to hit X to the -1, and then I'm going to go to B. And that gives me my two answers. So I know for stock A, he originally invested $1,000, and stock B, he originally invested $2,000. Okay, if you're solving it using your matrices on your calculator, you still have to make sure you are defining your variables and you're setting up your system. Okay. All right, last word problem. This one, looking at this one, you do have three different things. So we're talking about candy bars. You have a Snickers. I don't like using S because sometimes it can look like a 5. So I'm just going to say N is my Snickers. I have Milky Ways, so that's going to be M. And then I have R for Reese's Cup. All right, so a little bit about each one. So I know you have a total of 120 candy bars. So however many Snickers plus Milky Way plus Reese's Cup, you have a total of 120. So that's one equation. The other equation is talking about money. So realize all of those talking about money are going to go in the same equation. So for Snickers, it was $1.25. Milky Way was $1.75. And then Reese's Cup was $1.50. And that was a total of $1.75. Okay, so looking at that, that would be my next equation. The last equation, it can get a little confusing. So he ordered 10 fewer Milky Way bars than Reese's Cups. So you have to think about which one did he have more of. So looking at this, he ordered 10 fewer Milky Way bars than Reese's Cups. So I could put the Milky Way bars. He ordered 10 fewer than the Reese's Cups. So that would be R minus 10. Okay, so 10 fewer than the Reese's Cups. And that would equal the Milky Way. Now, if I'm setting up a matrix to solve this, I do have to have all my variables on one side of my equation. So for this equation, I would need to move that R over to the other side. So, and I have to line it up. So that would be M, and if that's a positive R, it would be a minus R on that side. So make sure if you are solving this using a matrix in your calculator, you have all your variables on one side. Okay, so now I can go through and I can type this in. My matrix is going to change. So when I look at this matrix, realize when I start to set this one up, you're going to have a 3 by 3. And then here I don't have an N, but I do have an M and I do have an R. So make sure you still hold a space for that N. So looking at that one, this would be my first matrix to set up. Okay, so this is going to be a 3 by 3. So I need to change those. So now I'm going to plug all these in. So I already have 1, 1, 1, 1.25, 1.75, 1.5, 0, -1, or sorry, +1, and then -1. So that is a 3 by 3 matrix. So I need to go back and edit B, which is going to be, so remember B is your solutions. So that would be the 120, 175, and -10. So that one is a 3 by 1. So I have 120, 175, and a -10. So now I can type everything into my home screen. So I got my A to the -1, and then I got B. So looking at this, and again, we have to remember the order of my variables. So I know, looking at this, N is first. So when I look at that, or write it. So N would be 50, that's your Snickers. M is equal to 30. So that's your Milky Way, and your Reese's cup would be 40. Okay, so again, if you're using matrices for your word problems, make sure you're setting up that system over here the correct way. So make sure you can show that work on your test. All right, sorry. All right, the last part of this, we got some more equations to solve with matrices. So looking at this, I need to solve for x. I need to get this x by itself, solve it like a regular equation. So I am going to take this 5 and distribute the 5 to that matrix. So that's going to be a 5, 25, 20, and 15. So I am simplifying this first. Everything else I am just bringing down because I haven't done anything else with the other matrix. Okay, now if I want to get this 3x by itself, just like you would solve a regular equation, I need to move this matrix to this side. So I'm going to subtract this one over here. So it's going to cancel out on this side, and I'm going to subtract it over here. Okay, so that gives me 3x equals, so now I'm subtracting these. So 14 minus 5 is going to give you 9. 22 minus 25 is -3. 8 minus 20 is -12. And then 18 minus 15 is 3. So I've gotten the 3x over here by itself. So remember, I distributed first, and then I took this matrix and moved it over there by subtracting. Now I've got to get the x completely by itself, so I've got to divide everything in that matrix by 3. So 9 divided by 3 is 3. -3 divided by 3 is -1. Whoops. -12 divided by 3 is -4. 3 divided by 3 is 1. So that would be my solution. That is what x equals. Okay. Next one, exactly the same thing. So I am going to go ahead and distribute this 4 to that matrix. So I'm going to multiply everything in there by 4. Again, bring everything else down because I didn't do anything else to the other matrix. Same concept. I need to move this matrix over here, so I need to subtract it over there, so it's going to go away on that side. So I am going to subtract that matrix. Realize right here, I still have a -1/2 left. So I'm subtracting everything. So I'm doing 3 minus a -8 gives you a +11. 9 minus 16 gives you a -7. And then I have -2 minus 12 is -14. And then 6 minus -4 is +10. Okay, so again, I just subtracted those two. So now I've got to get this 1/2 over here. It is a -1/2. Now, this is where you can use your calculator on this section. So looking at this, if they are multiplying by -1/2, you have two options. I can divide everything by a -1/2. It might look a little weird by dividing by a fraction, but you can do that in your calculator. You do need to be careful in your calculator. So if I'm doing 11 divided by, and if you're using the division bar to put in your fraction, you need to put that fraction in parentheses. If you don't, your calculator will give you the wrong answer. So if you're typing it in like this, you have to put parentheses around your fraction. Okay, so that does become a -22. That's option A. Option B, we've talked about in class. If you have a fraction left on this side, you can multiply by its denominator to get rid of it. So you can either divide by -1/2 in your calculator, or mental math might be easier to multiply everything by -2. You get the same answer. So either way you want to think of it. Okay, I kind of ran out of room, so I'm going to write the answer down here. So that is a -22. If I do -2 times -7, you get a +14. Or if I want to do -7 divided by the -1/2, you get a positive 14. Either way you want to think about that. Okay, -14 times -2 is 28, and that should give you a -20. So that would be your solution. Okay. So with solving for matrices right here, solving for that variable, you treat it just like a regular equation. All right, very last step, very last problems. So this is still systems, but remember these were the 3 equations, and looking at this, it does say that you have to solve it by elimination. So we cannot use the matrices in our calculator for this. So on your test, you're going to be looking for work to solve it by elimination. So this is where you can just pick any 2 equations to start with. It does not matter which 2. So I am going to start with the first 2. So I have 2x plus y minus 3z equals -14. And I am going to get the x's to cancel first, so that means I need to multiply this equation, everything, by 2. So that becomes a 2x minus 6y plus 8z equals 44. So all I did was multiply that whole equation by 2 so I could get the x's to be the same. Now that I have them the same, I'm going to subtract. 2 minus 2 cancels out. So then I have 1 minus -6. So 1 minus -6 does give you a positive 7y. -3 minus 8 gives you a -11. So make sure we're subtracting everything. So I do have -14 minus 44, and that's going to be a -58. So that was my first step. I used my first 2 equations and I got my x's to cancel. So the second step, because I got my x's to cancel here, I have to get my x's to cancel again. So on the second step, I still want these x's to cancel out. So that means if this is a 3, I've got to multiply this equation by 3. So that becomes 3x minus 9y plus 12z equals 66. The other equation, that bottom one, I am just copying over. So now same concept, I'm going to get those x's to cancel, so I'm going to subtract because 3 minus 3 gives me 0 and cancels out. I have -9 minus 2 is -11y. 12 minus 1 is going to give you a positive 11. And then 66 minus 0 is just 66. So your first 2 steps, you are trying to cancel out the same variable. So now that I have both of them canceled out, so now I can merge these. So I have, this is my third step, so I have 7y minus 11z equals -58. And I have -11y plus 11z equals 66. So this one works out nicely. Those are already the same. I don't have to multiply by anything. They are opposite signs, so I am going to add the 2 equations together. So 7 plus -11 is -4y. These cancel out and go away. And then I have a -58 plus 66 gives you 8. So when I divide by -4, you get -2. So one solution is -2. Once you get this solution, the rest is a little bit easier. Remember, now I can plug this back into either one of these equations. It does not matter which one, you're going to get the same answer. Okay, so I'm just going to plug it back into the first one. So I'm going to plug it back into this one. So 7 times -2 is -14. And then I have the rest of the equation. So I'm going to add the 14 over there. So I have -58 plus 14 gives you a -44. And then divide by -11. So z is equal to a positive 4. So now I've got 2 of my solutions. This is where I can now go back to one of the originals and plug both of those in. Again, doesn't matter which one, you're going to get the same thing either way. I'm actually going to use the last one just because I see the 0 there. So I'm going to plug in, so I have 3x. I know y is -2. So 2 times -2 is -4. And then I know z is 4. So this actually works out nice because -4 plus 4 cancels out, and I'm left with 3x equals 0. If I divide by 3, x is equal to 0. Make sure you can write your answer looking at the ordered triples. So when I write my answer, this answer would be 0, -2, 4. So that would be my solution. And you can check your answers by using your calculator if you would like to. So then I could put that into a matrix and check it in my calculator and see if I get the same answer. You know you did everything correct. But this is the work I'm going to be looking for on your test for these systems right here. Okay, last one. All right, so same exact operations. So first, and I'm going to put like a little line here because I feel like it's going to start to run into those other problems. All right, so looking at this, pick 2 equations. I'm going to pick the first 2 because I don't have to multiply by anything. They look pretty easy to work with. So here, again, I'm going to get my y's to cancel out for this one. So if I get my y's to cancel, they're opposite signs, so I'm going to add the 2 equations together. So x plus x is 2x. Those cancel out and go away. Don't forget this is a 1. So 1 plus 3 is 4. And then -1 plus -3 is -4. So that's my first step. I got y's to cancel out. So because I got my y's to cancel out on that step, I have to get y's to cancel out on my next step as well. So now I have to use these 2. And again, if I want to get y's to cancel out, I don't need to multiply by anything because they're the same number. They both have a 1 in front. So looking at this, I'm getting y's to cancel. They're opposite signs, so I'm going to add the 2 equations together. So 1 plus 2 is 3x. Those cancel out. 3 plus 2 is 5. And then -3 plus 0 is -3. So this one worked out nicely for those y's because I didn't have to multiply by anything on those first 2 steps. So now I can combine these. So now looking at it, I'm going to get my x's to cancel. So if I want x's to cancel, I now have to multiply that one by 3 and that one by 2. So when I rewrite it, that's 6x plus 12z equals -12. And multiply everything here by 2. So that would be 6x plus 10z equals -6. They're both positive, so I'm going to subtract so that they cancel out. 12 minus 10 is 2. And then again, just double check, be careful of your negatives. I have -12 minus a -6, and that gives me that -6. So z is equal to -3. So now I know what z is equal. I can plug it back into either one of these. Doesn't matter which one, you're just plugging it back into one of the equations that just has 2 variables. Okay, so I'm going to plug it back into this one. So if I plug that back in, I'm going to have 2x, and then I'm plugging it in here. So 4 times -3 is -12. So then when I solve for this one, I'm going to add 12 over here, which gives you a +8. So x is equal to 4. So now I've got 2 of my solutions. I can go back to the top part. So now I can plug these back in. I'm going to plug it into the first one. So x I know is 4. I don't know y. And then z, right here is a -3, so I'm going to put -3 equals -1. So simplifying that, 4 minus 3 is I'm trying to figure out where to put it. I have a -y, 4 minus 3 is 1. And then if I move 1 over here, I'm going to subtract. So that's going to give me a -2. And I'm going to divide by that -1. So y is a +2. So I kind of ran out of room. You can probably do this on another sheet of paper to keep it a little bit more organized, okay? But looking at this, when I write my answer as that ordered triple, I have 4, 2, and -3. Okay, and again, I can type this into my matrices in my calculator and check my answer, and hopefully I do get that answer. All right, so I know it's a lot. It is tied pretty much everything to systems with your matrices. So systems comes back into play in Unit 4. A lot of information. Make sure we know how to graph without using the calculator. Find that intersection point. Graph those inequalities using your dotted line, straight line, shading. Okay, and then all of the operations with your matrices. So make sure you go all of this so that you are prepared for your test.